All right, great. Hey, listen, good morning, everybody. We have Maximus with us today. And today we're actually going to be covering something pretty exciting in the sense that we use logic every day. And one thing that we're going to be talking about is an introduction into reasoning and proofs, and specifically patterns and conjectures. All right. So what I want you to do, Maximus, is go ahead and read this next slide.
Vocabulary word, conjectures. Drawing a conclusion on what you think might happen based on what you observe. Example, if you notice the ground and all the roads are wet.
Yeah, so if this is the case, what should I write down here, Maximus? If you notice that the ground and all the roads are wet, what do you think happened?
It rained.
Yeah, it rained. And that's exactly what they call a conjecture. A conjecture is you're making, from an observation, you're making like, oh, I think this is what happened, right? Okay, Now let's go ahead and now move on to the next one. All right, so Max, read this one.
Vocabulary word, counterexample. An example that shows that a conclusion is false. Example, all prime numbers are odd.
Yeah, so give me a counterexample to the statement. Like, give me something that shows it's false. Yeah,
all numbers are prime.
No. All prime numbers are odd. So it's basically saying, like, if you think about all numbers, it's saying that numbers 1, 2, another prime number is 3. Remember, prime numbers are numbers that are divisible by itself and 1. 1, 2, 3, 7. Okay. Now, are all these numbers odd?
Yes or no?
No. Which one is not odd?
2.
Yeah, the 2. Exactly. So because of this is the reason why this is a counterexample. It shows that it's something is false. So it's not always true. So even if it's just one case, you can't say it anymore. You know, it's like you got to look at it and say, you know what, this is different. This is new. So because of that, this is a good example of a counterexample, just showing that it's false. Okay, it just needs to fail one time, and that's why it's false. All right. Now let's go ahead and do the next one. Max, read this one.
Vocabulary word, pattern, an arrangement or ordering of things. Example, 3, 6, 9, 12, 15.
Next one is what?
What is the next number in this pattern?
Yeah, what is it?
3, 6, 9, 12, 18.
18, yeah, exactly. Yeah, so that shows you just a pattern. You know, you're starting to, and it's kind of like a conjecture. Does it make sense? You're seeing an order of things, and you're like, okay, well, the next one's probably this one. Now, let's go ahead and do the next one. And then, all right. Now, when you see this ordering of things, what do you think is going to be the next missing shape?
Probably the heart.
Yeah, the heart. Exactly. Good. Now, let's do the next one. So now read this one.
Inductive reasoning, the process of drawing conclusions based on your observation.
Yeah, so based on his observation, what is next? How is this supposed to look like?
The second one, but opposite.
Yeah, like that. You see what it shows? So inductive just means that you're going the other way around. It's kind of like an observation where you're saying, okay, so this one, and it's the same thing as saying, okay, this is 1, this is 2, this is 3. You would assume that the next one is 4, right? That's the same thing, but in this case, it's a little different. All right, now let's go ahead and do this next thing. All right, now I'll do this one. Well, actually, Max, what would you think? Okay, using inductive reasoning, what do you think the next 3 terms are on this one?
Next 3 terms, it looks like they're minusing by 5.
Yeah,
so the reasonable answer would be 25, and 20, and 15.
Exactly. And you went ahead and took that because inductively, you said there's a -5 in each one of these. Does that make sense? So then that's how you came up with that solution. All right. And
yes.
We were right, right? Okay, now let's go ahead and, now if you're doing inductive, what is the next shape on here to draw?
They looks like they draw a diamond and then they draw a square, so the next one should be a smaller diamond.
Yeah, yeah, and I think and you're right. And probably the best thing for me to do. Hold on, let me see if I could do this for a second. I'm gonna see if I could try to snip out this piece or kind of redraw it. So it starts there, and then you make another one, but it's based off. Let's see. You know what? It might be easier just to draw it, but it's basically this shape. And really, what they did is that the next step would be
To twist it.
this, yeah, and then they'll continue doing this. But
Mm-hmm.
inductively, and that's what it's going to look like. You notice that how they went ahead and did that. So that's how they came up with that response, that result. All right, now let's go ahead and now do this one. So, what is your conjecture about the 20th term of this pattern below? Well, let's go. Let me help you. 1, 2, 3, and then 4, and then we repeat, don't we? Notice that? Notice how this goes back to 1, 2, 3, and 4.
You could just do 4 times 5, and that means the last letter would be R then.
Yeah, exactly. And then so that's how you come up with that solution. You know, so same thing, using conjecture, and you're kind of saying, okay, I'm seeing this, so this is what I'm going to do next.
Yeah, 4 letters.
Mhm.
I'm just going to go. Then what's 20? 4 times 5, 20. That means the 4th letter.
Yeah, you're definitely right, Maximus. All right, now let's do the next one. And yeah, so there it is. Exactly your explanation written down. Every 4 terms, or it's 20th, multiple of 4, 20 term also has to be R. All right, now what about this one, Maximus? Read it.
Flower is red, then it is a rose.
No, but read where it says example 4.
Write a counterexample for the statement below.
Yeah, so the flower is red, then it is a rose. Why is that false?
Because many flowers could be red.
Well, no, that's true, right? Like, give me a flower. You know one offhand? What about like a carnation? You seen this carnation before? This could be many different colors.
Any other red flower got a weird name. I don't know.
Yeah, so, and then here they said a tulip. Tulips are also red. Yeah, they're also red, but it's not rose. So that's a counterexample. In this case, it shows you this red tulip says, hey, I got an example that shows you that you're wrong. And it's not always right, so you can't say that.
I see.
Okay, so now next one, read this one.
When you multiply...
No, but always read the directions.
Okay, example 5. Write a counterexample for the statement below.
Yeah.
When you multiply a number by 3, then it is also divisible by 6.
Okay, why is this wrong?
Because something lower than 6.
Well, yeah, so there's a couple of things. If you multiply this by 0, don't you get 0?
And
There's 0 divisible by 6.
Multiply by 1.
Yeah, if you multiply by 1, you get 3, it's divisible by 6. Now most people are thinking, okay, if I multiply by 2, I get 6. It is, that one does work out, but because of these, and this is a counterexample showing you just need one. But if you have multiple, then it shows you like more proof. All right, so, and here they use 5. All right, now let's go ahead and read this one.
Write a counterexample for the statement below. One and only one plane exists through any 3 points.
Yeah, what do you think?
False. You could have as many points as you want on that one plane.
Here's the reasoning.
No?
Well, no, well, in this case, if you have 3 collinear points, okay, you can't call it a plane if they're collinear. Because actually, well, yeah, then you have more than one plane that could go through there. And when I'm talking about specifically, let me show you right here. Here's a point, here's the collinear points. And as a result, if you have 3 or more collinear points, Well, I'm saying if you have 3 collinear points, that one could count. You could have a lot of planes going through those 3 points. Make sense?
Yeah.
You connect more things to it. So good. All right. So now, all right. So this is pretty much just a reflection here. So really the most important thing for you to do today is make sure you write down the notes, make sure you understand the vocabulary terms, because tomorrow we're going to build upon this. So it's important to know what you're doing. But apart from that, hey, Maximus, thank you for joining us today. All right, go ahead and say bye to everybody.
Bye, everybody.